respect to the physical properties, boiling point comparison between aldehyde, ketone, carboxylic acid, alcohol, and alkane. The table is available in NCRT. We have also discussed it already. When you compare between alcohol and carboxylic acids have higher boiling point than alcohol because their ability of doing stronger hydrogen bonding. Here, this hydrogen goes for the hydrogen bonding. This oxygen is connected with the carbonyl group, which is electron withdrawing. So this makes this hydrogen much more electropositive here. So it makes the corresponding hydrogen bonding much more significant. So carboxylic acid has higher boiling point compared to your alcohol, compared to aldehyde, compared to ketone, and then comes alkane. The next physical property is solubility. So the more is the non-polar group that you have, that means the R group that you have, the least will be the solubility. So usually till 4 carbon system, they are soluble, not more than that. The next one is the synthesis. A very common question with respect to aldehydes and ketone synthesis comes with the usage of alcohols, where you use oxidizing agent here. The very common question is PCC because it gives you a retarded oxidation where it stops with aldehyde. Copper, which is also a retarded oxidizing agent where it converts a primary alcohol into aldehyde. Thionyl chloride reaction and its importance. The next one is the conversion of gem dihalide to aldehyde. And you have RCHCl2 is here. To hydrolyze it, followed by dehydration to form aldehyde. The next one is Itard reaction, where you convert toluene in the presence of chromyl chloride to form benzaldehyde. So all the naming reactions in particular that we have covered here is important. There is no discrepancy. No, this comes first, this comes first. But I'm talking about the synthesis part. All the namings are important for us. Let it be Gatam and post, let it be Gatam and aldehyde. Any reactions that you have seen are important. Reimer, Tiemann, Coles reactions, anything is important for us. But when I'm talking about the reaction and specific, aldol is compulsory, 100%. We expect aldol reaction, but don't expect it very simple. They will give you a product, they'll ask you how many aldols and canizeros have happened here. These are very common questions here. So aldol, usually you
Ma'am,
expect, tell me.
in this, how many aldals and cannons are like? It will include like geometrical isomers, optical isomers, right? Totally that because the number will be a lot higher if it will include optical isomers.
No, no. For example, I'm having like this kind of a Product is provided. They have given you formaldehyde plus methanol here. How many reactions have happened between them in the presence of NaOH to give this following product? So they
Oh,
should have went for cross aldol. How many cross aldol reactions have happened here? That kind of questions.
okay.
The next reaction come upon is Canizero. The common question here is crossed Canizero. So the least hindered will become as acid and the another one will become as an alcohol. It's a disprop reaction. The oxidation states, change in the oxidation states are very common here. This goes for Canizero. So first thing you have to concentrate on aldol and Canizero here. For JEE advanced level, the questions here belongs to whatever we have further studied, like Perkin, Hominogel, benzoin, Fomotsky, Wittig. These questions appears in JEE advanced level. These aldol and Canizero are the primary ones that appears for your JEE mains level. Of course, the reaction about acetal formation. This appears in mains level. They use dry HCl, you form acetal, hemiacetal, and the protecting group, ethylene glycol. Its priority to go and attack the aldehyde at first. These kind of questions are common for us. And in mains level, the next question is Grignard reactions. They're treated with the Grignard reagent. How many Grignards are used? What is the product that we get here? Remember always for JEE, it's not only one single step reaction. When the question starts, the question could have started from hydrocarbon chapter and it ends with ketone. Possibility is there. Where they use this hydroboration reaction and then the reaction went on. Possibility is there.
Yes, ma'am.
Okay. Further, once we complete all these questions, always practice your questions from exam side. That is the right platform for you to practice your questions here. Because this gives you the clear idea, picture, what is being importantly questioned here. That is important. People can give you random questions, but which is a classification, which is a type of question that you expect comes from exam side. Okay, once you complete the reactions that are specified for aldehydes and ketones, the acidity of the aldehydes and ketones, with respect to their substituents that are present in it. That is very common here. Substituent means with respect to their inductive effect. Chlorines and bromines that are substituted at the alpha position and the beta position. That is important for us. Okay. So with this, we complete the chapter aldehydes and ketones. Surya, you have not even submitted me alkyl halide assignment. So I will send you the assignment for alcohol, ethers, and phenols today, as well as aldehydes and ketones. So try to complete it and send it to me, everyone. Okay, da?
Yes, ma'am.
Yes. So we'll go on for the next chapter, carboxylic acids. The primitive one with respect to carboxylic acid that we have to learn is acidity of carboxylic acids. I have CH3COOH and HCOOH. The moment when I say acidity, the first thing that you should identify is release their H plus. What you form is CH3COO minus. Identify the strength of this ion. In both the cases, it is involving in the resonance. But here I am having a plus-I group. Here I don't have this plus-I group. We know very well a plus-I group, electron donating group, will decrease the acidity. It's completely understandable that formic acid will be more acidic than acetic acid. If I compare formic acid with benzoic acid, what we generally expect, ma'am, benzene is there, ma'am, benzene is electron withdrawing nature, so definitely it should be more acidic. Actually, formic acid is more acidic than benzoic acid. That means it is having less pKa than benzoic acid, because here when I compare this benzoic acid, the richness of this phenyl group, which is having the plus, I think whenever, let me say, you are having this carboxylate ion on the benzene, which is more electron withdrawing. Obviously, this is more electron withdrawing compared to benzene. But the benzene is actually showing plus or effect here. So this will keep donating the electron to this carboxylate ion, which is more electron greedy compared to benzene itself. But hydrogen, though it is greedy here, hydrogen doesn't have anything to provide here. So formic acid is more acidic than benzoic acid itself. The question appears in reason and assertioning statement here, where formic acid has low pKa than benzoic acid. This is the assertion. The reason is benzene shows lesser effect.
Yes, ma'am.
The next thing is with respect to the acid. Let me say I'm having CH3, CH2, CH2, COH. With respect to the inductive effect, chlorine is here, fluorine is here, fluorine is here, which will have least ionization constant value. What is ionization constant? The need for it to release this H plus so that it gives the negative charge. So in this case,
Ma'am, so which is more acidic?
least ionization constant அப்படின்னா it will be least acidic.
Oh, yes, ma'am. Least acidic.
So I have CH2Cl here if it is releasing H plus. You can see the negative inductive effect is present in the alpha carbonates. So definitely it should be most acidic here. The more acidic is that, more it is ionizing. The more it is ionizing, more will be the ionization constant value. You can see it is present in the beta carbon. So it comes up to the second. This will be the first one, highest ionization value, second ionization value, and this will be the one which is having the least ionization value. Okay, we are discussing about the acidity trends of the carboxylic acids. I have CH3COH. I treat it with sodium bicarbonate. So whenever you are having this carboxylic acid unit, they try to release the carbon dioxide from sodium bicarbonate. Will form CH3COONA plus CO2 plus H2O. The carbon dioxide is released from sodium bicarbonate. Sodium bicarbonate is a weak base. So you need some strong acid only to generate. You need a stronger acid to generate this carbon dioxide from sodium bicarbonate. Ma'am, but acetic acid itself is a weak acid only. We are not comparing it with sulfuric acid. Among carboxylic acid we are talking about. So, for example, the question usually appears with phenol versus this carboxylic acid. Which is more acidic here? Obviously, carboxylic acid is acidic. Phenol, ma'am, I have seen this phenol releasing H plus to form phenoxide ion, ma'am. You could, but it is not as strong as it compared to carboxylic acid. In order to make the sodium bicarbonate work, you need a stronger acid here. So phenol will never release a carbon dioxide from bicarbonate. Not possible. Clear, huh? So you need definitely a carboxylic acid unit here to treat it. So they'll give you benzoic acid, okay, nitrobenzoic acid, phenol, para-nitrophenol. How many of them will release carbon dioxide? This will release carbon dioxide. This will release carbon dioxide. This will also release carbon dioxide because phenol is becoming acidic here because of the nitro group. So that will that will have the ability of being acidic here. So release the H plus here. Okay, so that it will release carbon dioxide from sodium bicarbonate.
Yes, ma'am, got it.
Okay, yes. So we will continue in our next class then. Keep working at your NCRT, that's very important for you. Okay, bye.
Thank you, ma'am.
Yeah.